Welcome to the Physics Bible. Today we're going to look at CP1, which is the motion section of the EDEXCEL Physics GCSE. Let's get started. What I recommend you do is, after I've read the question, pause the video, take on board any hints or tips that I've given whilst reading the question, do some research if you're unsure of the answer, and have a go at it yourself. When you think you've had the best go that you possibly can, unpause the video and see how well you did. If you write the questions out and then put your answers underneath, you'll obviously have your own copy of the questions and answers that you can revise from later. Question number 1. What's the difference between a vector and a scalar? Well, obviously this question bases itself around two words, vector and scalar. We need to know what the definition of a vector and a scalar is. So here's a good example for you to try out the method. Pause the video, write down what you think the difference is, what the examiners would be looking for, and then unpause and see if you're right. If you're unsure, why don't you get your revision guide or look online and see if you can find the answer before you check. If you're going to do that, pause the video now. Okay, so a vector is a quantity which has a direction and what we call a magnitude or a size. So the difference between the two is that a scalar has a size, but a vector have a direction also. So for example, mass is a scalar, 5 kilograms, 10 kilograms, but weight or a force, that's a vector because it has a size such as 10 newtons, but also a direction. A force has to act in a direction as well. Question number 2. Name two vectors and two scalars. Well, I've already given you a couple. See if you can find another two which are different to the ones I've already given you. If you're unsure, have a check in your revision guide. Pause the video now. Okay, so some typical vectors, you could have momentum, weight, acceleration, displacement, velocity. There's probably a few more. Like I say, you'll be able to find them when you look them up. Scalars. Sometimes you can try and figure out what the scalar version is of a particular vector. For example, displacement, the scalar version is distance. And for velocity, the scalar version, we would just call it speed. So these two are actually scalars. Question 3. We've got an equation here. Speed equals distance divided by time. If a car travels 2 kilometers in 100 seconds, what is the speed? So you're going to have to use the equation and get an answer. Be careful, make sure you pay close attention to the units. The distance is in kilometers, the time is in seconds, so think about what your unit of speed will be. Okay, well, we should always write the equation down first, but because it's already there, I'm not going to do that. But I am going to put the numbers in that I've got. So I write speed equals, the distance is 2 kilometers. I can write km, but I don't have to. I can just write the number 2. So 2 divided by distance divided by time, which is 100 seconds. Now, this will give us quite a small number, but it doesn't necessarily mean that it's a really small speed, because actually our unit is going to be kilometers per second. So we're going to get a final answer of 0.02 kilometers per second. Now, if you wanted to turn that into meters per second, have a think about that. And I'm going to tell you in 3 seconds. .02 kilometers per second. To turn it into meters per second, we would times by 1,000 because there is 1,000 meters in a kilometer. Move the decimal place 3 places to the right. 1, 2, 3. So that would be the same as 20 meters per second. If the question tells you you have to put it in a certain unit, then you may have to change it, or you could have changed it at the start and actually done 2,000 meters divided by 100 seconds, which would give you the same answer as 20 meters per second. Question 4. If a car travels at 30 meters per second, how far will it travel in 15 seconds? We've been given bits of information here. I do recommend that you highlight. You can bring highlighters into the exam, or underline the numbers you're given, and maybe write next to them the letters that they represent in the equation. So 30 meters per second and 15 seconds are the numbers we've been given. But what do they actually stand for? Well, meters per second is a speed, so I'm just going to write the letter S there, and 15 seconds is a time, so I'm going to write the letter T there. So what I've got is S and T, and what I have to find, if a car travels, how far, I need to find the distance. So I'm trying to work out D. At the minute, the equation is not in the right form to find distance. At the minute, it's set out to find speed. So, have a think about that, have a go at it, pause the video if you need to. Right, so to get this, we have to rearrange the equation to get D equals. Now, whatever we do to the right hand side, we do to the left hand side. To get rid of T and leave D on its own, we're going to multiply both sides by T. So what's going to happen is that T is going to move up beside the S, and we're going to get distance equals speed times time. Now, if that's something that you still find particularly difficult close to the exams, make sure you talk to your teacher and ask them to go through rearranging equations with you. Being able to rearrange equations is worth a lot of marks on the exam papers. So now it's in this form, we just put the numbers in. D equals, speed is 30 and the time is 15. 30 times 15. Of course, you're allowed a calculator in the exam, so don't take any risks. Make sure you use it even if you think you can do it in your head. And that gives us 450. The units, well, meters a second and seconds. The unit of distance, in this case, is going to be meters. So 450 meters is our final answer. Question 5. It's a graph. Don't be scared by these. Once you can do them, they're actually easy marks. Always pay attention to what's on the axis. Here, we've got a distance against time graph. In a distance time graph, you can find out how far something's gone, but you can also calculate the speed from the gradient of the line. So we've got a graph that is split into 3 sections, A, B and C. Question is, what is the speed at section A, B and C? So you have to work out the speed. To do that, obviously, it's not just going up the side, because that's telling us distance. To get speed from a distance time graph, you have to work out the slope, or what's called the gradient. To do that, well, pause the video, have a go. If you can't do it, then we're about to do it in a couple of seconds. Okay, so the speed at section A. Remind ourselves of the equation. Up here, speed equals distance divided by time. The distance travelled in section A is 20 metres. So the speed is going to be from 0 to 20, and the time it took was 4 seconds. So section A would be 20 divided by 4, which is 5 metres per second. Section B. It gets a little bit tricky because we can't just count from 0. For example, the length of time spent in section B is not 6 seconds. Section B starts here, where the gradient changes, and it goes from 4 to 6 seconds. The distance would be from 20, and it's actually stayed at 20. So a flat line on a distance time graph means that the object is stationary, 0 metres per second. The distance hasn't gone up, there is no speed, there is no gradient. The last section, again, what we should do is make a shape out of the line and think, how much distance has it travelled, which is going to be this section here. So we're going from 20 metres up to 50 metres. So that section is worth 30 metres. And along the bottom, how long did it take? Well, it started at 6 seconds and it travelled up until 7 seconds. So it's actually only 1 second. So speed equals distance, 30 metres, divided by 1 second, which gives us a speed of 30 metres per second. Question 6. This is a question using the acceleration equation. Acceleration equals v is our final speed, u is our starting speed, and t, that's the amount of time it takes to change speed. So the first question, Mr. Percy goes from rest to 100 metres per second in 10 seconds. What is his acceleration? Pause the video, give it a go. Okay, so we're asked to find the acceleration, so we don't have to change the equation around. We just have to make sure we put the right numbers in the right place. The final speed here, well, I go from rest to 100 metres per second. Rest is just another way of saying no speed, 0 metres per second. And that is our starting speed, which is u. 100 metres a second is my finishing speed, and 10 seconds is the time. So A equals 100 minus rest is 0 divided by the time, 10 seconds. Do it on a calculator, although even this one you shouldn't need a calculator for. 100 divided by 10, which is 10. The units for speed is meters per second, but remember for acceleration is meters per second squared. Number 7. V squared minus u squared equals 2ax. So what do these letters stand for? same as above. That's our final speed. That's our start speed. A is obviously acceleration, and X is, particularly at EDEXCEL GCSE, they use X a lot for distance or displacement. They don't use the letter D, so remember that X stands for distance. The question is, Mr. Percy accelerates from 2 meters per second to 8 meters per second. Okay, with an acceleration of 1.5 meters per second. How far did he travel while accelerating? So we need an equation that starts with X, because it's asking us how far did I travel, and X is the distance. So to rearrange that equation, we have to move the 2a, so we get X equals v squared minus u squared divided by 2a. Put the numbers in. Make sure you write out your working, just in case you make a mistake on the calculator. You'll get marks for showing that you knew that these numbers go in the right places. The final speed is 8, so it's 8 squared. The start speed was 2 squared, and 2 times a, 2 times 1.5. I can simplify that a bit more. 8 squared is 64, 2 squared is 4, and on the bottom there, that's 3. So 60 divided by 3, which is 20. And because it's distance, it's in meters. So 8 squared minus 2 squared, because the final speed was 8 meters per second, the start speed was 2 meters per second, and it tells you the acceleration is 1.5. What value is g, the acceleration due to gravity? Now, this is something that, if it's not given to you, you just got to know. The letter g stands for the acceleration due to gravity, and it's different depending on what planet, or to be honest, wherever you are in the universe. But at GCSE, we just need to know that g is always going to be 10 meters per second squared, the acceleration unit there. So on Earth, it will always be 10. This question requires a little bit more working out. The question is, what speed will Mr. Percy hit the floor if he falls from a cliff and hits the bottom after 5 seconds? Well, that's not very nice, but let's see if you can figure out the answer. What speed? So we're after speed. Think about what else you've been given in the equation and see what equation is going to help you answer that question. Okay, so in this question we've got speed, which in these equations here is v, so I'm going to write v. We've also got time. Now if we look at this equation, time is not in that, so it must be this one. So we need to rearrange it to get v equals. To do that, we multiply by t to get v minus u equals at, and then we add the u to the other side, so we get v equals u plus at, or at plus u. Put the numbers in. Well, it doesn't tell you what u is, apart from the fact that if you fall from a cliff, you can expect that your downward speed is 0 as you fall off, and then obviously you're going to speed up towards the floor. So your starting speed is actually 0, so we can just forget about it, and then it's just acceleration times time. And the clue was in this part. The acceleration on Earth due to gravity is 10, so the acceleration will be 10, and we accelerated at that rate for 5 seconds. So if I was to fall off a cliff and fall for 5 seconds, hit the floor, I'd hit the floor at 50 meters per second, which would be the end of Mr. Percy. Okay, question 9. We've got another graph. Don't be scared. Just look at the axis again. This time it's different. It's v, which is a velocity, and t, which is time, so it's a velocity time graph. So there are certain things we can get from this graph that we couldn't from the last graph. We can get the velocity just by looking at the side. We can get the acceleration, which is the gradient or the slope, or we can get the distance, which is the area underneath the line. So that's a quick recap. Let's see if we can use that to answer these questions. First question, between what times is the car travelling fastest? Well, that's just asking when is it travelling at the fastest velocity, which is just how high up on the graph it is. So here we're travelling at 5 meters a second, then we're getting faster, and then we stay at 15 meters per second. We start at 4 and go to 7. So the answer is 4 to 7 seconds. B, calculate the acceleration of the car between 2 and 4 seconds. Pause the video and have a go at it. So the acceleration is the gradient on a velocity time graph. It says between 2 and 4 seconds, so I'm only interested in this section of the line. To work out the acceleration, form a triangle, because what we want is the gradient of that section. So it's going to be y divided by x, the change in speed divided by the time it took to change speed. So the change in speed is we started at 5 and then we finished at 15. So 15 minus 5, the change is 10 meters per second. That's how much we sped up by. And it took 2 seconds to do it. Which I don't need a calculator for. 5 meters per second squared. If the question asked what the acceleration was between 4 and 7 seconds, what would you think that would be? Well, what's my change in speed? I'm at 15 meters per second and I stay at 15 meters per second. So the acceleration is 0. There is no change in speed. There is no slope, there is no gradient. A flat line on a velocity time graph means there's no acceleration. Finally, what is the total distance travelled by the car? For this, we actually have to break the graph up into as many rectangles and triangles so that we actually fill the complete area underneath the line. So I'm going to colour the triangle area in green. I'm going to colour this area in blue. I'm going to colour that area in black and that area in red, because this would be for quite a few marks on an exam, 3 maybe 4. We have to work out the area, because the distance is the area underneath the line. We have to work out the area of all of these sections and then add them together. So let's start with the first one in red. The area is just the length times the width, so 2 times 5. I'm going to write d equals to show that I know that I'm working out the distance. So the first section, 2 times 5. The next section, the black section, Well, the length is 2 to 4, which is 2, and the height is 5, so it's the same again. So we're adding another 2 times 5. The blue section is another rectangle. It goes from 4 to 7, so that's 3 times, and it goes from 0 to 15. So we're adding 3 times 15, because the height is worth 15. And finally, the green section, the triangle, well, we've already showed that that's worth 2 and that's worth 10. But remember, with a triangle, the area, you have to divide the 2 times 10. You have to divide it by 2 because it's a triangle. So we get 2 times 10, but remember to divide it by 2. Otherwise, it would give you the area of that whole section there, and obviously that isn't underneath the line. So we split it in half to get the area of a triangle. Add that all together. We've got 10 plus 10 plus 45 plus 2 times 10 is 20, divide by 2, which is another 10. And so our final answer is 75 meters. Not so bad, is it? That's the end of CP1, the motion section. The next video is going to be on CP2, forces in motion. Join me for that one. Hopefully you've got the hang of it, and I'll see you there.